Hey Calculus, we are going to learn how to do U substitution. U substitution is a process that allows us to take the derivatives of composite functions. A composite function is a function where one function is built into the other. There's an outside and an inside function. Just think, if you can use the chain rule to take the derivative of the function, then you can use U substitution to take the antiderivative. All right, so let's look at our first example. It is a composite function. There is an outside function cosine and there is an inside function 5x. The 5 in front is going to come along for the ride. So we're only going to do U substitution on this part of it right here. Okay, so the first step in U substitution is to take the inside function and rename it U. So that's our first step. Our inside function here is 5x. So we're going to make U equal to 5x. That's the first step. The second step is to write the differential. So use the shortcut. There's 3 steps. U becomes du. We take the derivative. The derivative of 5x is 5, and you toss dx on the end. So your differential needs all 3 parts. U becomes du. You take the derivative and you toss dx on the end. Okay, before we do the third step, it helps to go up and diagram your problem. The third step is we have to replace everything in this equation with either u's or du's. There can't be any x's left. So here's what's going to happen. All right, I'm going to kind of diagram here. This right here, the elongated s and the 5, is going to come along for the ride. Since this right here is our u, 5x, we can rewrite this piece here as the cosine of u. All right, and I know the antiderivative of the cosine, so this piece is going to be replaced with the cosine of u. So now we ask ourselves, what is left? Well, here's what's left. The dx is left. Now, whatever is left has to be all by itself on one side of your differential equation. All right, I need dx all by itself, but I have 5 dx. So that third step is to adjust the differential. So in order to get dx all by itself, we need to divide both sides by 5. All right, I'm going to divide both sides by 5. So it's going to look like this. All right, if I divide this by 5 and I divide this side by 5. All right, now on the left, this is the same as 1 du over 5. So I'm going to rewrite that and I'm going to pull out that coefficient. All right, so it looks like this. 1/5 du is equal to, the 5's cancel out here, so it is equal to dx. And that is your third step. All right, you need to get whatever is left after you plug in u all by itself in your differential. All right, now the fourth step is we're going to rewrite the entire integral. All right, so the elongated s and the 5 come along for the ride. This piece here gets replaced with the cosine of u. And now I need to replace dx. All right, and I use my differential. What is dx equal to? All right, dx right here is equal to 1/5 du. All right, so now I've replaced everything and I only have u's and du's. There are no x's. So let's just diagram the original problem. All right, the elongated s and the 5 come along for the ride. The cosine of 5x gets replaced with the cosine of u, and the dx gets replaced with 1/5 du. All right, so I've replaced everything. So now we're at step 5, and step 5 is to finally be able to take the antiderivative. If you've done it correctly, you should know what to do with everything here. So when you take the antiderivative, the notation drops out. The elongated s and the du drop out. the coefficients, the numbers come along for the ride. So I bring along 5 and I bring along 1/5. So those come along for the ride. 5, and I'm just going to make that a fraction, and 1/5. So there should only be one thing left. Here's what's left, the cosine of u. Whatever is left, that's what you take the antiderivative of. I know that the antiderivative of the cosine is positive sine of u plus c. So again, there's three things that are going to happen with everything here. It's going to drop out the notation, it's going to come along for the ride, any numbers, and if you should have one thing left, and that one thing is what you take the antiderivative of. All right, the sixth step is to finish it up. You simplify it and plug in u. All right, so if we simplify it, the 5 and the 1/5 cancel out. So I have the sine. Now I plug in u. All right, and I go back up here, my u is 5x. And there is my antiderivative. Ta-da! All right, now let's check. To check, you take the derivative. To take the derivative of this, we need a chain rule. All right, so let's go and try that. The derivative of the outside function, the derivative of the sine, is cosine. The inner as is 5x. And the derivative of the inner is 5. And that was my original integrand, the function right up here, 5 cosine of 5x. All right, let's go to the next one. Step 1, rename the inside function u. Our inside function is 7x plus 4. So u is equal to 7x plus 4. First step. Second step, you write the differential. So the u becomes du. You take the derivative of this. The derivative of 7x is 7. And the derivative of 4 is 0. And then you toss dx on the end. So your differential, I can't emphasize enough, needs all three parts. U becomes du. You take the derivative, and you toss dx on the end. Now you go up and diagram the problem. All right, so it looks like this. My u is 7x plus 4. So I can replace this piece right here with u to the 9th. All right, I know how to take the antiderivative of u to the 9th. That's a power rule. So this piece is going to become u to the 9th. The elongated s, of course, is going to come along for the ride. So now you ask yourself, what's left? dx is left. Whatever's left after you plug in u has to be by itself right here. I need dx all by itself, but I have 7 dx. So my adjustment is going to be to divide by 7. Divide both sides by 7. So it looks like this. On the left, I'm going to have 1/7 du. du divided by 7 is the same as 1/7 du. And on the right, if I divide this side by 7, the 7s are going to cancel out, and I'm left with dx. And that was my goal, to get dx by itself. Okay, the fourth step is to rewrite the entire integral. All right, so the big elongated s comes along for the ride. This piece right here gets replaced with u to the 9th, and now I need to replace dx, so I go down to my new adjusted differential. Dx right here is equal to 1/7 du. All right, so again, this elongated s came along for the ride. 7x plus 4 to the 9th got replaced with u to the 9th, and dx is being replaced by 1/7 du. All right, so there we have it. Now we're ready to move on to the fifth step. The fifth step is to finally take the antiderivative. So when you take the antiderivative, the elongated s and the du drop out. The 1/7 comes along for the ride. And the one thing that we have left, that's what we take the antiderivative of. That's a power rule. The antiderivative of u to the 9th using the power rule is u to the 10th over 10 plus c. All right? The sixth step, we simplify it. Now, I'm going to pull this coefficient out front. When I multiply 1/7 by 1/10, that becomes 1 over 70. And then I have u to the 10th plus c. So you always want to pull the coefficients out and just make one coefficient at the top. Now the last thing we need to do is plug in u. My u is equal to 7x plus 4, so that goes right here. 7x plus 4. And there you have it. There is my antiderivative. Okay, now of course we want to check. Remember, you check by taking the derivative. So when you take the derivative, the 1/70th comes along for the ride. The outside function is 10, so the derivative of the outer is 10 times something to the 9th, and I'm going to put that over 1. The inner as is goes right here, so that's 7x plus 4. And don't forget, the third step of the chain rule is to take the derivative of the inner, and the derivative of the inner is 7 over 1. And now look what cancels out. On top, we have 10, right here, 10 times 7, which gives us 70, and that's going to cancel out the 70 there. So we're left with our original equation right there. So we did it right. Yay! Okay, last one. First step, u is your inside function. My inside function here is negative 2x. So u is equal to negative 2x. Second step, I write the differential. U becomes du. I take the derivative. The derivative of negative 2x is negative 2, and I toss dx on the end. Now I'm going to diagram. The elongated s up here is going to come along for the ride. This piece here is going to become u. My u is going to be right here, so this piece can get replaced with e to the u. And I know the antiderivative of e to the u. So now what's left? Well, dx is left. Whatever's left after you plug in u has to be by itself right here. All right? I have negative 2 dx, but I need dx all by itself. So my adjustment, of course, is going to be to divide by negative 2. All right, so my new improved differential, if I take du and divide it by negative 2, it's going to become negative 1 over 2 du. And if I divide the right side by negative 2, the negative 2's cross out, and I'm left with dx. And that was my goal. All right, the fourth step is to rewrite the entire integral. So the elongated s comes along for the ride. This piece here, e to the negative 2x, we're going to rewrite it as e to the u. And I'm going to replace dx. I'm going to go down here to my adjusted differential. dx is equal to negative 1/2 du. Negative 1/2 du. All right, so I have replaced my original integral with only things that have u's and du's in them. So the elongated s came along for the ride. E to the negative 2x got replaced with e to the u, and dx got replaced with negative 1/2 du. All right, the fifth step is to finally take the antiderivative. All right, so we know that the notation, the big elongated s and the du drop out. We know that the negative 1/2 comes along for the ride. So the one thing that we have left is e to the u. That's what we take the antiderivative of. And the antiderivative of e to the u is itself, e to the u plus c. And now I plug in u. So negative 1/2 e to the negative 2x. Up here we know that our u is negative 2x plus c. There you have it. Now take a second and check. All right, check by taking the derivative. Negative 1/2 comes along for the ride. The derivative of the outer function is e to something. The inner as is negative 2x. And the derivative of the inner is negative 2 over 1. And these things here will cancel out. Negative 2 and negative 1/2 cancel out. And you're left with what you started with. That's your substitution. You just have to practice it. The more you do it, the better you will get. At the top of this note sheet are the steps in detail. So you'll have them there for you to read through. All right, thanks, calculus.